This is Professor Malcolm Clark, and some people have told me that he's probably the one person who knows most about squid and sperm whales in the world. So this is a capacity, and you have a chance to be with him for a while. What do you say if someone acclaims you as being one of the foremost researchers in the field of squids and sperm whales?
Well, if you put the two together, there aren't very many people that do those two animals together. I do them together, and I'm sort of known in the world of studying squids, and I'm known in the world of studying sperm whales. So, yes, sure, there aren't very many people with those dual interests. In fact, there may only be one.
How come you have these two interests together?
It came about really because I worked for an Institute of Oceanography in the UK, and we were finding terrific difficulty in catching squid. Squids are very difficult to catch in the open ocean, and then I opened a sperm whale. Prior to that, I'd actually worked as a whaling inspector in the Antarctic, and I opened sperm whales, and I found the most wonderful big squids, which were far and above bigger than anything that man ever catches, and of totally different species. So the sperm whale stomachs provided me with all these new interesting species, and when I got back to England I found that no one really, except a Russian, had looked at these from the point of view of finding out what they were and what interest they had. So it all came really through the sperm whale, and after that, although I studied the other squids most of the time, the squids that were caught in nets, and I sort of developed methods of catching them. I couldn't ever do anything like as well as looking in predator stomachs, and the best predator to look at for many of the squids was the sperm whale, because it eats so much, and so that sort of developed that link.
So your initial interest was in the sperm whale as someone yielding the objects of your research to you, but then you became interested in the sperm whale themselves.
Yes.
How did that happen?
Yes.
Or what aroused your interest there?
Well, I got interested in the spermaceti of the sperm whale, because that's apart from well, physiologically the sperm whale is doing a very extraordinary thing. It's going from the pressure of 1 atmosphere and in a short time going to very high pressure in the sea of something like 100 atmospheres. So that it's having a tremendous change in life, and if you look at other things that it changes as it dives, so the light disappears. First of all the red light and yellow light disappear, and it goes down and it goes into a blue world and then into a black world quite quickly. The intensity of the light drops off tremendously fast in the sea. So it's changing to a black. It's getting much lower temperature because the temperature of the sea drops as you go down, and it's also getting a change in pressure, and the change in pressure combined with the change in temperature mean that its density changes relative to the water. The density gets, the water gets sort of thicker and heavier, and so it's got this problem that it is pushing to go down. Well, the sperm whale spends a large proportion of its time diving deep for food for the squid, and so it's got all these difficult problems to deal with, and I got very fascinated by how it dealt with these problems when no other animal, anything like as big, could do it. Some smaller ones do it, but they have slightly different problems. So that made me think of the problems it was facing and what special anatomical and physiological tricks it had to deal with it. And of course the big difference with a sperm whale is it has an enormous nose, which is very difficult to account for. It's full of a very special wax called spermaceti wax, and this is the one really defining feature of the sperm whale, its nose full of this wax. And so I found that by looking at the nose and seeing its structure, everything fitted a theory that what the whale was doing was cooling its nose in order to be in dense deep water, so that by cooling its nose it can actually make itself heavier or denser. So this can match the water.
So it's like a submarine that changes its specific weight in order to dive.
Yes.
And changes the weight again in order to surface. So the
sperm
right. whale has an apparatus that allows for that.
Yes. It probably doesn't use it actually for it helps it down and it helps it up possibly, but the critical thing is when it's down there it can adjust to the buoyancy of the water so that it doesn't have to keep swimming to stay down. And a sperm whale of about 45 tons, which is an average big male, is fighting an upthrust of getting on for 100 kilos push if it goes into this deep water. The compression of its lungs changes its density, but that's all operates in the top 200 meters. If it's going down and wanting to control it below that, deeper than that, then it's got to have some other method. And this is the perfect method because the wax in the nose actually freezes or goes solid anyway, begins going solid at 30 degrees centigrade. So with its at 38, it has a method of heating it, and with its with passages in the nose into which it can take water, it has an ideal method of freezing it. Did I say freezing? Yes. So it's got the means to change it, and if you do all the calculations, it has the possibility of doing it at the temperatures that it's at. And this means that anywhere in the world, even in the tropics where the surface might be 27 degrees, if the whale dives, it can go to 7 degrees, so that it can get a 20-degree change in perhaps 10 minutes. And this is an immense change in temperature and buoyancy in a short way. So the sperm whale can do this in the hottest water at the surface, or it can do it in the Antarctic where there's very little change between the two. And apart from the advantage it has for balancing when it's down there, when it swims, it apparently does a lot of gliding, and if it's coming down, it can glide down if it's changed its density, or changing its density, and it can glide up as well. So it's got that facility both ways. Otherwise, it would have difficulty one way or the other. Anyway, that's the buoyancy.